Hello my dear friends, welcome to our program for chemistry, third secondary stage. Today we have this session in two parts. The first part, we have the types of cells and we complete this one, and we have the corrosion of metal that happened and what are the losses of this one, what are the benefits and what are the harms of this part of chemistry. Start with me and concentrate with me very well. Let's start our session today. Lead acid battery. We have this lead acid cell. I have two parts. We have lead and we have that acid. This acid or this cell, it contains two parts, the lead and the lead compound, and we have the liquid. What is this liquid here? We have H2SO4, 6 mole per decimeter cube. Means what? It means it's very concentrated one. And we have the anode. It's very important to know the anode and cathode of each cell. The last cells that we said before, or that we illustrated before, and this cell. And I need to know the type of this cell and how many volts that produced in EMF or electromotive force of each one of them. The anode, lead frame containing spongy lead. The second one, insulating spacer. And we have the cathode, it's positive one. Cathode is positive, yes, in this case we have positive one. Lead frame containing lead oxide. And after that, the anode plates are connected together. And here the cathode plates are connected together. And again, in last time we have the part here or the liquid or the electrolyte here, it's what H2SO4 more concentrated. After this part we have the lead acid. It's a kind of batteries that are developed into becomes the most suitable kind for batteries in cars. The car battery, it's a container made of plastic, made of fibers that contains two poles, negative and positive. So here we have this kind that contains liquid inside, and we have the whole of these cells dipped inside, or the spongy lead and the lead that's dipped inside together inside what? Inside the liquid here as an electrolyte. So these types of cell, we have it consists of 6 cells connected to each other like this in this shape. So it is A, and this is A, it means anode, it is negative. And we have B plus, its cathode is positive here. Why? Because here we have the types of liquid that found between them. It's 6 cells. Each cell makes the reaction. Each cell produces E cell equal to volt. Between the positive and negative, between lead and spongy lead. We have E cell, it's equal to volts. And the total cell potential of the battery is 2 times 6 cells equal 12 volts. So our cars that moves by 12 volts, yes, it's very little amount. Yes, I need this 20 volt to make the contact here to start the motion of our car. But the lead acid cell here, it's one of the secondary cell that I need if I need to recharge it by another battery from another car. I connect between them by the wires to make the recharging again. And the total cell potential of the battery is EMF equal 2 times 6 equal 12 volts. 6 cells, each one that has 2 volts or produce 2 volts, we have 12 volts. After this one, the lead acid cell, it is possible to manufacture large volume batteries, contain more than 6 batteries when it's needed. What's meant by this? I need to make a large battery, like our desk, for example, desk box or anything of this, any volume. So it's possible to manufacture it, because if I need to make large or a big battery, I need more than 6 cells. I put 12 cells, for example. I put 36 cells, for example, to increase this battery, and I dipped all of them completely inside what? Inside the H2SO4 concentrated. So it is possible to manufacture the volume of batteries contain more than 6 batteries when it's needed. So when is needed, I have the anode. I need to know the reaction or what's happened in the negative pole. It is anode here. This is a spongy one, spongy PP or spongy lead. It's a metal or it's an element. So they are connected to each other in the negative part. And we have the lead plate filled with spongy lead. And the other part is positive one. It's blue color, we have positive. And here we have spongy, it's what? Negative parts. So this one, it's the negative and positive poles. So the spongy lead plate, lead plates filled with spongy lead. So we have the lead and spongy one. And this one, after that, we have the lead acid cell. This is the battery in this battery. The anode is the network of the lead filled with spongy lead, PP. Again, the anode is the network of the lead filled with spongy lead. And the negative one, the cathode. We have lead plate filled with what? With the lead dioxide. We have here this one, it's the lead dioxide. It means what? It means a compound that start the chemical reaction between them. Here we have the red color, it is the negative pole, and the positive pole is blue color of what? Of lead dioxide. So the cathode, it is positive pole, lead dioxide plates or sheets of lead dioxide to make the reaction or to start the reaction between this lead and lead dioxide and the H2SO4 concentrated. So the lead acid cell, it makes what? It makes the cathode is lead network filled with the paste of lead dioxide, PPO2. It's very important to know this. I have the major or the common question here. Compare between lead acid cell and mercury cell or dry cell or galvanic cell or Daniell cell, any one of them. I need to know the anode, cathode and the total reaction and what's happened in each one of them. So the network filled with the paste of lead dioxide, PPO2, and the plates are separated from each other by stimulating or insulating sheets. So we have insulator between these two sheets, between lead and lead oxide. So this is the lead acid cell, and we have the structure of this cell from inside. We have the H2SO4 that found here as an electrolyte, and we have the anode, lead. It's what? It's the filled with the spongy lead. And after that we have the cathode or positive pole. It is green color. Here again we have the cathode, it's green color here, that refers to the positive pole and filled with PPO2, and the anode lead grid filled with what? With the spongy lead. So this one, it's what? It is the structure of the car battery from inside. If I need to recharge it, I connect this battery to another battery, okay, in series connection. So it makes what? It makes the recharge again to make the reaction or to start the reaction for a little time, for a little period of time. Again in last time, H2SO4 electrolyte solution, and the lead grid filled with what? With the spongy lead, okay, and the cathode lead grid filled with what? With PPO2 or lead dioxide. So this is the structure of the cell. It's very important to know this, to make it drawing or to try to draw these things. Lead acid cell, all which are dipped in the dilute sulfuric acid solution and is conducting the electrolyte, and all of these are put in the container made of plastic to prevent, or fibers, to prevent the reaction between them, to prevent the reaction between the fibers and H2SO4 or the container and the H2SO4. If I have a type of container that are made of, or that is made of iron or zinc or anything like this, we have the reaction between the H2SO4 or sulfuric acid and this metal. So we have, I don't need this reaction between them to make another new cell inside the lead acid cell. So all of which dipped in dilute sulfuric acid solution as the conducting electrolytes, okay, to all parts of this container. and made this container made of rubber, solid rubber, polystyrene, or what, or plastic, or anything like this, which is not affected by the acid, which is not affected by any reaction with H2SO4. So the battery, and the battery works as galvanic cell. So the galvanic cell here, it's one, or this car battery, it's react as galvanic cell. Why? Because it has one direction, but if I need to charge it, I make recharge again for a period of time. So the total reaction, very important to study this, occurring in the nickel cadmium cell. For example, it is one of this cadmium cell or nickel cadmium cell. So NiO, IOH plus Cd, okay, or cadmium 0 plus H2O. It is the same thing or similar to the car cell. So here NiOH by 2 plus CdOH by 2. So here this is the reaction or total reaction, and here the EMF of this one 1.3 volts. Like what? It's similar to what? Similar to the car battery that has 12 volts. Why? Because each cell it has 2 volts and I have 6 batteries dipped inside what? Inside H2SO4. And here the total reaction occurring in lead battery cell is what? Is PP plus PPO2 plus 4H positive, it's H2SO4, and we have 2SO4 negative 2 as an ion or as the anion. So here PP again lead plus lead dioxide plus 4 ions of hydrogen plus 2 ions of SO4 negative 2 gives us what? PPSO4 plus 2H2O. If I have this reaction, it is one direction. So here I have nothing after this one, and the EMF is equal to volts of each sheet. But here the total EMF is what? Is 12 volts, because we have 6 sheets or 6 cells. Each sheet represent one cell. So after that, the reaction occurring in lead battery cell at anode, PP plus SO4 negative 2, they are lead, react with H2SO4, forming lead sulfate plus losing 2 electrons. Again, we have the reaction occurring in lead battery cell. It is very important to know this. We have at anode, we have lead, is the anode, negative pole. We have the lead plus SO4 negative 2 give us lead sulfate plus 2 electrons, losing 2 electrons. This is anode, and the EMF equal positive 0.36 volts, the first one. And the second part, or cathodes, we have the cathode, it is the positive pole. We have the lead dioxide plus 4 hydrogen proton plus SO4 negative 2, it's H2SO4. We have the reaction between them. 2 electrons that lost gained give us what? Give us PPSO4 plus H2O. So here we have in the first one, here in this one or this type of battery, we have the anode, we have PPSO4 that formed, and in this part we have PPSO4 that formed with what? With water. So here the total EMF is equal 1.69 by positive. So here the meaning of positive or negative, it is the direction, just direction, okay? And here we have 1.69 volts plus another one. So the total is what? The total is 2 volts for one sheet. And if I have 6 sheets again, we have 6 sheets plus times 2, okay, equal what? Equal 12 volts for the whole car battery. Now we have a small exercise about what? About the calculation of EMF of this car battery. We have exercise here, calculate the EMF of the lead acid battery. What's happened here? We have our solution. The total EMF, it's 1.69 plus what? Plus 0.36. They are by volts. 1.69 at cathode, it's positive pole, and we have at anode, negative pole, it's 0.36. The total is 2.05 volts. It's nearly or approximately we have 2 volts. So one of these sheets is 2 volt. If I have 6 batteries here, we have what? We have 12 one. Another type of these batteries, we have lithium ion battery. It's a dry. And this is rechargeable battery used in mobile, laptop, and the modern cars instead of the lead acid battery. Why? Because this type of battery, it's the lighter and store large amount of energy while it is small in size. Due to what? Due to the material that used in each one of them according to chemical activity series, or the series of what? Of the potential. So the chemical potential or electric potential series, we have what? We have the lithium, it's more active than zinc, more active than iron, more active than lead. So it has the reaction more than the other one. So in this battery, because it is lighter in the weight or lighter in its mass, and store large amount of energy while it's small in size. So after that, we have another one. The metallic cover of the battery contains 3 thin layers rolled in the spiral shape this layer are. So the spiral shape, it means it increases the surface area to make the reaction, to produce the large amount of electric energy, or it makes chemical energy. So the structure contains lithium because it's the lightest metal and it has the lowest reduction potential, negative 3.04 volts. So here the structure contains lithium. It's one of the properties or one of the useful things that found in this battery, because it is the lightest metal. It's the smallest one, lightest one, and it has the lowest reduction. It has highest one of what? Of the oxidation. So it start the chemical reaction very fast or very strong. So the cathode, number one, or the first part, the cathode is positive electrode. In this case, we have the cathode is positive electrode because it is one of the secondary cells, which is made from lithium, cobalt oxide, lithium and cobalt oxide. So here this is cobalt oxide, COO2, and we have the lithium with them, mixture between them. At anode, we have negative electrode in anode, which is made from lithium graphite, LiC6. So it means what? We have 2 different compounds. We have a mixture in the first one, Li, lithium, cobalt oxide, and we have the anode here, which is made from lithium graphite. So it is very light one. And we have the isolator, which the isolator here, it's found in this case, we have its very thin layer for what? It's made of plastic. So this one is isolator, it's plastic, so it doesn't make any reaction completely to keep what? To keep the electric energy and chemical energy inside. After this one, we have which is separate between the anode and the cathode, but it's allowed, okay, allow for ions to pass through it. So which is separate between the anode and cathode, but it doesn't allow for ions to pass. This is the function of what? Of the insulating. But in the first one, we have lead acid, we have some kind or some amount of this electron that move between these 2 poles. So it makes what? It makes the reaction or small batteries inside the battery. But here we have nothing of this. These thin layer are dipped in the anhydrous electrolytic solution of hexafluorolithium phosphide. Again, hexafluorolithium phosphide. It is very, very important to know this one. And we have, this is the electrolyte. It is like what? Like H2SO4. But H2SO4, we know it before. But here we have hexafluorolithium phosphide, LiPF6. Okay, so we have 1 atom of lithium, 1 atom of phosphide, and we have 1 or 6 atoms of fluoride. So here we have the shape here. Between what? Between these cathodes and the anode. The electrolyte. We have the first one. We have discharge. Discharge, it means it moves from anode negative to cathode positive. Through what? Through the wire. To make operation of what? To make the operation of the mobiles or laptops or anything. And in the other side, at left hand side, we have the recharge figure. Okay, this figure here that represent the recharging here. Between what? Between the cathode and anode. If I put the source of electric energy to this battery, it makes the reaction again to make or to start the chemical reaction from first part to make what? To make the operation of the mobile or laptop again, and vice versa. It is irreversible. It is reversible reaction, not irreversible, because it is recharged one. It's very useful to make this. So we have this lead, or we have the galvanic cell. It makes a corrosion of the metals. Corrosion here, it means what? It means the metal corrosion causes heavy economic loss of lead, leads to what? Leads to the destruction of the metallic structure, and especially that are made of iron. But how can we make the keeping of iron? So the mass of iron that may be lost due to what? Due to the corrosion can be estimated by 1/4 of the production of the whole world every year. So I need many things. Hence the interest, okay, in these phenomena, okay, and try to overcome and process chemical corrosion of these metals by what? By environmental effect that known as rusting. Okay, the mechanism of corrosion, how this mechanism or how this corrosion make this losing of the metal. In most cases, okay, the corrosion, in most cases of the corrosion, the pure metal is different. Even the iron doesn't rust easily, takes long time because it's in pure state, it's very pure state. So after that, we have the most industrial metals are always contain different impurities that activate the corrosion process. After that, we have this contact between what? Between less active metal and the more active metal causes corrosion as small cells. We have the reaction between metal causes the corrosion for the active one with the in the same medium with another metal, okay, that's less active than this. So here, then we can conclude that, okay, the corrosion of the metals are formed due to the formation of galvanic cells, in which the anode is corroded element. After that, while the cathode, we have the anode, it starts the chemical reaction to make the corrosion, but the cathode, which is less active one, or carbon, that exist as impurities in this, which cause the erosion or the corrosion of each one of them, of these metals. After that, iron and steel. So we have the piece of iron like this, and the piece of iron, it makes what? It makes the water, or absorb some amount of water. Iron plus water give us, with the presence of oxygen and the heat energy from the sun, it makes rusting. So the cathode here, it makes the water change into hydroxide ion, and we have iron change into iron positive 2 aqueous solution in the presence or by losing 4 electrons. After that, we have, when the piece of steel exposed, the cracking or to cracking or to breaking, so it will form, okay, the galvanic cell with the water, which contains dissolved ions. Dissolved ions, it means here the ions of iron that dissolve in water in the presence of oxygen. After that, that act as the electrolytic solution, and the iron act as anode. So the oxidation reaction that takes place at the following equation. So this is the erosion or corrosion of what? Of the metal here. Okay, this ion or iron positive 2 becomes a part of an electrolytic solution. So, and the electrons, okay, transfer. And the carbon impurities in the iron through the piece of iron to the cathode. so the iron act as anode and the external circuits. Okay, so this is the meaning of or the corrosion of each one of them, of these metals. So here we have two things here, or we have two pools that make reaction, or that make small cells in each one of them to make the chemical reaction, cathode, and before it we have anode. So the cathode, which is less active one of the carbon that exists as impurities, and this which causes corrosion. After that, so the iron and steel corrosion mechanism can be explained as the following. We have the piece of iron and water here, and in the presence of oxygen, in the presence of heat energy. Okay, this heat energy from the sun, it makes corrosion, it makes rusting. So the cathode here, it makes the water change into hydroxide ion, and we have iron change into iron positive 2 aqueous solution in the presence or by losing 4 electrons. After that, we have when the piece of steel exposed the cracking or to breaking, so it will form, okay, the galvanic cell with the water which contains dissolved ions. Dissolved ions, it means here the ions of iron that dissolve in water in the presence of oxygen. After that, that act as the electrolytic solution, and the iron act as anode. So the oxidation reaction that takes place at the following equation. So this is the erosion or corrosion of what? Of the metal here. Okay, this ion or iron positive 2 becomes a part of an electrolytic solution. So and the electrons, okay, transfer, and the carbon impurities in the iron through the piece of iron to the cathode. So the iron act as anode and the external circuits. Okay. So the factors that cause corrosion, we have many factors that make classifying into two kinds. Factors specific to the metal itself, and we have the other one, we have factors specific to the surrounding medium. I have the metals, for example, the first thing. Number one, we have heterogeneous of alloys. What's meant by this? Metals that used in industry mostly exist in many shapes or many form of these alloys, which are difficult to be prepared from homogeneous structure. So the large number of local cells, we have the small cells that formed, which cause the corrosion of the more active metals. After this one, letter B, we have the connection of the metals, which are the points of welding metals together for using or using the screw made from the another metal. After that, it causes the formation of galvanic cells, causing the corrosion of the most active metals, as in the contact between aluminum and copper. My dear friends, I hope to enjoy your time with me. It's a very important session for studying. It has many information. Don't be confused, don't be irritable. So we have what? We have the questions to answer in your school book many times. Till we meet again in another session. Till we meet again, thank you and goodbye everybody.